Good evening. Today's video, we're going to discuss about theory of computation. In that theory of computation, the subject code is 21 CS 503. Myself, Sharmila, R.M.D.E. Engineering College, working in the Department of CSE. Today, we're going to discuss about that. Today, we're going to discuss about the non-deterministic finite automata. In that non-deterministic finite automata, they'll allow the input symbol from one to next symbol with the epsilon transition also is possible. A string is accepted only if there is at least one transition path starting at an initial state and ending at a final state. Two conditions in non-deterministic finite automata. One is current state and input symbol, there exists more than one next output state. So one or more transition is possible. Next condition is if there exists at least one transition path from starting at an initial state and ending at a final state is possible. That is two properties about non-deterministic finite automata. Using that, we're going to discuss one practice problem based on the converting NFA to DFA. So here, the first problem in this unit is converting non-deterministic finite automata to deterministic finite automata. Here, the problem one, convert the following non-deterministic finite automata NFA to deterministic finite automata DFA. The given transition diagram. There is a three states, Q0, Q1, Q2. Q0 is a start state because it indicates with the arrow mark. Q2 is a final state, it's with the double circle. Here the transition diagram for the given non-deterministic finite automata. By seeing the diagram, you can identify the Q0 state. If you give input A and B, it goes to Q0, Q0, Q1. Okay. In that transition diagram, if you give in the Q1 state, the input is B means that it goes to Q2. But in that, it's a final state, so you represent as asterisk. If the input is A means there is no transition. Then in the Q2 transition, there is no input symbol, so I write hyphen. Okay, here we are converting the Q0 from the transition table. If in the Q0, if the input symbol is A, it goes to Q0. In the Q0, if the input symbol is B, means it's go to Q0 and Q1. Next, we are choosing the new state. Present state is Q dash, that is Q0 and Q1. Already we have done for Q0. Now we are going to do the state for Q0 and Q1. In the Q0 and Q1, if we give that Q0 and Q1, if we give the input A means Q0 goes to A. If in the B, if we give the input B means Q0 goes to Q0, Q1, and in the Q1, if we give B means it goes to Q2. So you can write it as Q0, Q1, Q2. Here the new state is Q0, Q1, Q2. For that, we're going to draw a transition table for Q0, Q1, Q2. If we give Q0, in the input is A means it goes to Q0. In the Q1, there is no input for A. In the Q2, there is no input for Q2. Again, in the B input, if you give B input for Q0, it goes to Q0, Q1. If we give B input for Q1, it goes to Q2. In the Q2, there is no input state. If you give B, it will not go anywhere. So the input is Q0, Q1, Q2. Here, there is no new transition state occurs. So there is no new transition state occurs. Since there is a new transition, no new state are left to be added in the transition table T, we can stop the process. State containing Q2 is a final state. Wherever the Q2 contains, it's called as final state. In this table, the state final state is Q0, Q1, Q2. So here Q0, Q1, Q2, here Q2 is present because Q2 is a final state. So we are representing using an asterisk symbol. So we are drawing for this particular transition table, we are drawing a deterministic finite automata. What is deterministic finite automata? The del transition is Q cross sigma tends to Q. So only one element, one transition, next state transition. There is no epsilon input for the given DFA. So we are converting this transition table into a transition diagram. So what we have learned in this video is we have read what is NFA, what is the two properties of NFA, how to convert NFA to DFA. Whenever the new state occurs, we are giving the input for that new state, and we are creating a transition table. After creating a transition table, once the new state has stopped, we should stop the process and we should draw a transition diagram. Okay, thank you. I hope you understand this. Thank you.